Hello, welcome to the demonstration video for the optical beacon tracker for optical wireless communication by Group 4. Here's a list of specifications for the project. In this video, we're going to be demonstrating the beacon field of view, indoor functional distance, and reaction time for the project.
To measure the divergence of our beam, we have our prototype beacon array, an infrared camera, a target board, and the display for said infrared camera. After turning off our broadband light source, we can see the incident spot size of our beam onto our target board. Referencing the spot size on the camera, we can move a metal ruler until it just barely covers one edge of the beam. Then take another ruler and do the same thing on the other side. And we then measure the distance between them. In this case, they are approximately 12 centimeters apart. We then move the board a determined distance. In our case, we're going to do 50 millimeters. And we repeat the process. Once again, placing the metal ruler just on the edge of the beam. And again on the other. And measuring the distance between them, we get approximately 15 centimeters.
In field of view. Repeating the measurements for recording the beacon field of view 9 more times gives an average divergence of 37.7 degrees, which is just within the range of our specifications.
Here we have the GY271 IMU chip. Here we have it mounted above the QPD on the receiver. Here we have this unit circle already set with respect to north on the azimuth. Here we have the azimuth for our IMU chip, outputting about 110 degrees. So what we have here, now let's move it. We have about 180 on the azimuth. Move it as far as we can. We are about 200 degrees, the azimuth. For the GPS module, we're using the GY GPS 6MV2. The antenna is attached to the outside to avoid as much interference as possible. Our serial monitor tells us how many satellites connected, speed, longitude, latitude, and altitude. To demonstrate the servo motor, I will be using the simple library for the ESP32 servo that I used to calibrate the servo motors. This was done using the pulse width modulation by writing different microseconds and measuring their angle and taking the difference. Now, we we'll start with 0. It's position 0, 800. For our GUI, our ESP32 is running a DNSS and a Wi-Fi library. We are connecting locally, and here this will transmit all our data to azimuth, longitude, and latitude. And we can start and stop the program right here. This will stop. If I press it again, it'll start again.
Recording reaction speed. Improvements that could be added to the project are reducer gears added to our receiver system to increase our accuracy. We could add a PSU to improve our power efficiency, and we can modify our constructed rigs to improve mobility. This concludes the demonstration video for Group 4. Thank you.